know if you kept it or not, but I gave you that so just so you could see on that very first page, you can see a piecewise function, and it's just like two little rays, and it looks like just two little different segments of a graph, but there are certain situations when there's restrictions, and you would get a piecewise function. So we're going to practice graphing these, and then maybe do a crazy graph one. I feel like the ones that the Algebra 2 book does are really, really hard ones. So we're going to practice some like easy ones, and then we'll do like a crazy one and see about the domain and range. The domain and range on these can get a little weird, so let's see. Okay, is it okay if I go? Not go. Friendly was erasing a whole page, so I probably should wait on her. The nice thing about a short week is I woke up thinking it was Tuesday, and then I was so happy when I realized it was Wednesday.
There are some schools that only go Tuesday through Friday.
But they go longer because of
like
that.
an hour longer every day.
I may be more than an hour longer. Like they go to like 5, because they have to make up that time. Yeah. Like it's all about time. Or something like that. 4:30, something like that.
Well, I start at 7:30 if not.
Like, that wouldn't be enough time, I don't think.
Yeah.
That's only 4 extra hours for the week though, and we're here 6 hours, 6.5 hours, something like that.
Yeah, but you're cutting out lunch one day.
That's a half hour.
And an hour.
I think it's still about 6 hours we would need.
Each person has a period that they don't really need to take.
All right, write this down. It's all about hours though. They don't care about what you take.
We start at 7:30 and leave at 3:30.
Lots of schools started doing it when gas went up to save on bus routes, because you cut out bus routes per day, you cut out electricity use per day, air conditioner use per day. I know, but you know, just the price of everything going up.
It's only going to get worse.
All right, so I want to talk about kind of how these look. You're always going to have, it looks like more than one equation in one problem, because those are the different pieces of the graph. Because it still has to be a function, it still has to pass the vertical line test. So there's always going to be this stuff out here at the end. And these are your restrictions on your function. So I'm going to put restrictions. And those are really, really important, because you can only graph each piece for where it's true. So like on this one, we have two different functions. We have x minus 1, but we can only graph that when x is less than or equal to 3. And then we have the graph of negative 1, and we can only graph that when x is greater than 3. Most of the time, not always, because your book likes to throw some crazy ones in, but most of the time there's going to just be one number there, maybe two numbers if there's more than two pieces. And it's going to kind of meet up there, where one piece stops and the other piece will start. Not always. So when I do this, I always recommend starting with this. This is not really an asymptote in your graph, but this is a starting and stopping point. So when I make my graph, I always go to where it starts or stops, and I make a little dotted line to remind myself. So let me draw a little graph here. I'm just going to put like 5 spaces each way. Bless you. So at 3, at x equals 3, I'm just going to draw a dotted line. Because remember on our graphs, that's definitely not a straight line, but on graphs, when you make a dotted line, it means it's not really part of the graph. Just like asymptotes are not actually part of your graph, but it kind of just gives you some boundaries. This just lets me know that half of my graph is going to be to the left of this, and half of my graph is going to be to the right of this. You're never going to have two pieces on the same side of a line, because then it would fail the vertical line test. So you just start with one piece at a time. Do you know how to graph the line x minus 1? That's a linear equation, right? Slope-intercept form. Y equals x minus 1. So Brinley says we can go to negative 1 on the y-axis, I think she means. Because that means there's a y-intercept of negative 1. And then your slope is what's in front of x, which is just 1. So we could go up 1 over 1. You can also go down 1, back 1. Here's the thing with piecewise functions. You need to make it go all the way to where it starts or stops, like that dotted line. So going this way, we could just draw an arrow and we can just say it just goes that way. But we need to make sure we run it into this line because it's only true when x is less than or equal to 3. So do you agree it's only true up to this line, not past this line? So I'm just going to do my slope. You could just kind of connect it, but I'm going to go up 1, over 1, up 1, over 1. And I could say that this sort of looks like what my graph would be. Now I made a solid point here. It's really important to point that out. X is less than or equal to 3. Does it include when x equals 3? So I can make a solid dot there. If it didn't include that, we would have to make an open circle, just like on our piecewise functions yesterday, because if it's just less than or greater than, it's not going to include it. What? I mean step functions. Sorry. Okay, so we just graphed the line x minus 1. The only difference is we stopped it at 3. Now we need to graph the other line. This is the line f of x equals negative 1. We'll really struggle when it's just a number, but do you remember what that looks like? It's either going to be like this or like this. Because x equals a number, it looks one way, y equals a number, it looks the other way. Does this line have a slope? Is it no slope or zero slope? Like undefined slope or zero slope? Because could I write this as 0x minus 1? So what does that mean? Where would my y-intercept be? Negative 1. And what does a line look like if it doesn't go up or over any? If it's just flat. It's a slope of 0. So when you have just a number, y equals a number, or f of x equals a number, it's just y equals that number. But you got to be really careful here. Pencils are really nice because you could just graph the line, like I have a nice eraser, so I could just graph at negative 1, I could just draw that line in here. But that wouldn't be my answer because I'm only allowed to draw it when x is greater than 3. So I'm not going to start over here at the y-intercept. I'm going to jump all the way over to where I can start it down here. So that would be at 3, negative 1. I'm going to make an open circle here. Why is it open? Because it's only greater than 3. It's not including 3. And then it's just going to be that flat line going greater than 3. Does that still pass the vertical line test? Yeah, so it's still a function. If you ever make a graph and it's not a function, that means you've graphed it wrong because these will always be functions. So we've taken two different functions, graphed them on the same graph, and just picked a starting and stopping point from them. Does that kind of make sense? What if I asked you to find the domain and range of this? The tricky part about piecewise function domain and range is there's two different pieces of the graph. You can't just look at one side. You have to kind of put it all together and say, does it include all the x's? Or does the x start or stop somewhere? Let's look at one side at a time. What about this piece of the graph? Starting at x equals 3 and going to the left are all the x values chosen. That'll keep going forever. This line never stops, and no matter what x value you pick, do you agree that every x is used over here? What about this side? Starting here, this line's going to go forever this way. Are all the x values going to be chosen on it? Yeah, every x value we could line up down here. Here's a little hint. If your piecewise function meets up at that line together, your domain's going to be all real numbers, because although it's two pieces, it still picks every x value. So we can say all real numbers. We'll look at one in a minute maybe that's not all real numbers, so you can see what it looks like if it skips an x value. Now the range can be kind of crazy on these piecewise functions because especially when you have just a straight line.
So what about like if they both the equality signs were not included?
You're right. If this was just less than and this was just greater than, you're right. That would be an example of not all real numbers because it would be everything but 3. Do you agree with that? That's a good example. What about the range on this one? Are all the y values going to be used on these two little pieces of my graph? What about this side? What would be the range of just this part of the graph? Do you agree no matter where I go on this, I'm only at -1 on the y-axis? So if this was my only graph, the range would just be -1. Like one number would be your entire range. But we don't really have to put that in our problem because we also have this side. What would the range of this part of my graph be? Do you agree that it's going down forever? All the negative y values are going to be chosen, but it stops right here, and I heard someone say 2. It looks to me like this point right here is where it stops, and it never gets any bigger than 2. So I think we could say it's going to -infinity, so remember you have to write that first. Lots of people still write -infinity second. It goes from -infinity all the way up to 2, and is 2 included? Because it's a filled-in circle. Do we have to also say -1 is in there? Because -1 is in this range already. Let's say this line was up here at like 4, we'd have to include that. We'd have to say also 4, because it jumps up there. So you really have to think about domain and range when you're doing these. Let's do a more exciting one. Yes. If it didn't include this, if that was open, how would you write it on the range or the domain? The domain, you'd say everything but 3. So interval notation, if this was an open circle, you would say, you could say -infinity to 3, not including 3, and then from 3 to infinity. Or you could just say in set notation, x does not equal 3, which means x is everything but 3. Like definitely that's simpler when you have to just skip one number. But that's how you say it. You'd say it's every single number but 3 itself. If that was an open circle on the range, that would change to a parenthesis instead of a bracket, because it means it still would go up to 2, but it wouldn't include 2. Let's do 3. It's going to look intimidating, I feel. Well, there's 3 pieces. Like we have a part that's less than or equal to -1. We have a part that's in between -1 and 1, and then we have a part that's 1. So we have like 2 boundaries. We have -1 and 1. So go ahead and write that down and make a little graph, and we'll kind of talk through it. Again, I think a great place to start after you write the problem down and you make a little graph is putting those boundaries in, because it kind of tells you where your graphs are going to start and stop. We still only have 2 boundaries in this, although it kind of looks a little messy there. We're really only dealing with -1 and +1 and just what is on either side of it. So as you get these drawn, go ahead and draw in a boundary at x equals -1 and x equals +1. And like I said before, I think a really big thing to remember is you will only have one piece of your graph in each section. You'll never have it overlapping. So we broke this one into 3 sections, and we have 3 equations. So it makes sense. There's going to be one part to the left, one part in the middle, and one part to the right. Will the dotted lines ever be like this? No, because it's always going to be bounded by x values, and so it will always be vertical lines. So it's kind of up to you where you want to start here. I usually just start at the top. Some people like to start where they can actually start at 0, 0, since that's like normally we start on the y-axis. But I'm just going to start at the top like we did the last one. And if I graph the line x plus 3, if it wasn't a piecewise function, do you agree that we would just start at 3 on the y-axis and we have a slope of 1? You can still do that, especially with pencil, and it's nice because I gave you graph paper that you can just see the points and you can go back and erase it. What I used to do is I would always kind of like imagine, but not really make a point. I would go up to 3, and I would say, well, I'd start here, and I could go up 1 over 1, right? Is this the direction I want to be going? I want to go less than or equal to -1, so which piece of my graph am I dealing with? I want it over here. So could I go up here to 3? And how could I be going that way? What could I do with my slope instead of going up 1 over 1? Down 1, back 1. Would that be a point on my graph? And you could actually make the points and go back and erase it. It always works. Someone, I think maybe it was last year, maybe the year before, said, why would you do that? Why would you like imagine where it's going? Why not just start and say, what would I get when I plug in -1? Right? And that's another way to do it. If you plug in -1 here, what would you get as the y value? 2. So they said, why don't you just plug in where you want to start, -1, and go up to 2. And guess what? You get the same point, so it doesn't matter what you want to do there. Is that going to be a solid dot or an open circle there? Solid, because it is included. Have any clue what I'm saying? So it doesn't matter how you do it. You could do slope-intercept form, down 1 over 1, down 1 over 1, down 1 over 1. Or you could actually kind of just make a little XY chart and plug some numbers in so that you don't have to kind of make invisible lines as you go. If I graphed x plus 3, normally it would go all the way through this. But because I can only graph it when it's less than or equal to -1, it's just going to kind of look like that ray, like that. You need to make sure you put an arrow on it to show that it is going on forever. The part that actually includes the y-axis is the easiest part because you don't have to think about where do I actually want to start it. You can actually just start at what would be my y-intercept of 2x. 0, and it's between -1 and 1, which means I'm in this little bitty section in the middle, so I can actually start at 0, 0. This is like 2x plus 0. And my slope is 2, so that means I could go up 2 over 1. And is that going to be an open circle or a closed circle if I'm on x equals 1? Open, because it's not included. So I'm going to make an open circle right there. And again, you want to go to those boundaries. So we're not going to go anymore. We have to stop here. But we could go back to this side, right? So could I go down 2 and back 1 also to get another point? And is that one going to be open or closed? Also open because it's not included. And so again, I just get this little bitty segment of the actual line because I'm only graphing it when x is between -1 and 1.
Would that build out to 0 be closed?
Yeah, that's actually a dot on your graph. Like everything in between these two are included. The endpoints are the only time that you can make an open circle. Now x is greater than or equal to 1. That means I'm on this side of my graph. And we just talked about this. What is this line going to look like? It's just a number. Just horizontal line, and where am I going to start at? 4. At y equals 4 is what that line looks like. So at y equals 4, normally I'd go all the way through here, but I can only start it when x is greater than or equal to 1. So I'm going to start it right here, and I went ahead and made a closed dot because it is included. When you're done, you kind of just have a crazy little graph here, but you have 3 different sections that are bounded between -1, 1, and greater than 1. What about the domain or range of this? Domain can be what? Would it be all real numbers? Does everyone agree with that? Every x value to the left is used. We have a nice little closed circle here, so that's good. Every x value in here is used. This is closed. If it goes closed to open, open to close, and there's no jumps or breaks in your graph, if they all meet up, your domain will be all real numbers. This is kind of a good guess. Not always, but it's a good guess on this one. Range is very rarely all real numbers on this. It could be all real numbers, but with these pieces, it starts and stops, and so we have to kind of look at it and see what's going on. I kind of just start at the left and go over and kind of see if it keeps going forever or if it jumps. This side's going down forever. Do you agree with that? So definitely negative infinity is going to be part of my range. I just have to figure out where, if anywhere, does it stop. Stops here at 2. What if I jump to the next piece? It also stops at 2. Even though we have this line up here, do you agree that we need to say it stops at 2 because it does not include what's between 2 and my next line? Like, there's definitely a stopping point there. 3 is never included in my y values here. Is 2 going to have a bracket around it or a parenthesis around it? Because it is filled in here, even though it's not filled in here. And this is kind of what I was talking about on the last one. That straight line on the last one was down in our range already, so we didn't have to include it. We've included everything in this piece and everything in this piece. We have not included this. What would the range of this be? Just 4. There's no y value ever used, but 4 is always used. 4 is not in this, so we have to include it. And so the way that we write just a point is we just write a point. We could say the little union sign, and we just use the little brackets, and we say, oh yeah, 4 is also included. It's about the only time we ever write a range of just one number is when you have a horizontal line, piecewise function. Questions about that? All right, let's do a crazier one. Once you understand the idea of starting and stopping, open circle, close circle, they can really throw anything at you. And a couple of the ones on your homework tonight, which are from the Algebra 2 book, are like this. And I call this a crazy one because it skips over stuff. Like it doesn't meet up at nice points like on the last one. I would definitely recommend using pencil when you're graphing these. I don't have a little rule that you're not allowed to use pen, but it's really easy to make a point in the wrong part. The weird part about this one, well, not really weird, just I think more difficult, is notice these aren't like the last one. Even though it's only 3 equations, it's not just -1 and 1 that we are dealing with. We have to make a line at -6. We have to make a line at 2. And then we have to make another line at 4. And so there's definitely some places in our x-axis that it's going to jump over. We're still going to do the same thing. You just have to kind of maybe think a little bit more when you're doing it. So I'm going to go ahead and make my dotted lines, and then we'll see if we all agree. So at -6, I'm going to have a stopping point. And then at 2, I'm going to have a stopping point. And then at 4, I'm going to have a stopping point. The big thing I want to point out about this one is we have 4 sections of our graph that we've just cut this into. We have this far side, we have this side that includes the y-axis, and this little bitty section between 2 and 4, and then we have bigger than 4. We have only 3 equations and 4 pieces of our graph, which means there's going to be a piece that doesn't have a function in it. And to me, I think that's a weird piecewise function, because I like to think about every piece will fit into a little section, and this one is an example where it doesn't. So you want to just start with the top? 2x if x is less than or equal to -6, which means I'm all the way over here, right? So this is an example when maybe my method isn't as good as the method that someone gave to me. Because if the way that I used to do it, I would just use my eraser, and I would say, well, if I was going to graph this, my y-intercept's at 0, and I would go up 2 over 1, up 2 over 1, up 2 over 1. I just keep going until I got over to that section. Does that make sense that you could do that? It totally works every time. But some people thought it was a terrible idea and said, if I'm not going to start till -6, could I just figure out really easily at -6 what would my y value be? -12, right? Like an xy chart? And I don't know which way makes more sense to you. I feel like that way makes more sense. That if I just plugged in -6 here, it's like a little xy chart. If that's where I'm starting, I would just get -6 times 2, which is -12. Which means I don't even have enough places on my graph. Good news is your graphs today do. I'm just just going to make it go off the graph here. So at negative 6, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can be about right here. Oh, I didn't check. But it is a closed circle because it's less than or equal to. And then once you get that first point, can you just count your slope from there? Your slope it's always the same, so it doesn't matter where you start. Normally we just start at the y-intercept because it's easy to tell what it is. But from here, I could do a slope of 2. Slope of 2 would be like up to over 1. Can I make a point over here? No. So what if I go, what would I have to do? Go down 2 and back 1? Oh, that's terrible. Give me such a giant number problem. I should have made my y-axis go by 2. This is what I really should have done. It's too late for that. Can I just make it like this? And I'm just going to draw that line going in that direction. It is terrible. Well, I picked other ones for your homework, and then I took this off the homework that I didn't assign you. Probably why I didn't assign this one, because it was bigger numbers. But that's okay. We can still do it. Look at the next one. The graph of 5 between negative 2 and 6. Between negative 6 and 2, I mean. Negative 6 and 2. Here's negative 6. Here's 2. So this piece has to be in this big section in the middle, yes? What's that line going to look like? Horizontal, going through 5. 1, 2, 3, 4, 5. And it's just going to be that nice horizontal line. Make sure you get the open closed circle correct. And both of these are going to be, oh, I think I've done something wrong here, but that's okay. We'll just do this. One of those should really be open because now this is closed and this is closed. And it's not a function anymore. You want to make this one open? Is your life ruined if I did? Alright. I just typed it wrong. We'll try. We'll go with it. It's okay. What about this one? Negative 2x plus 1 for x is greater than 4. Which section am I going to be in?
Far right.
The far one, which means I'm skipping this little middle section. There's not going to be a piece of my graph there. So again, I'll show you my way on this one. You could just plug 4 in and figure out where you are. But if I start at my y-intercept of 1, slope of negative 2, I could go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. I think that's where I would start. Easy way to check. Plug 4 in, and you get negative 8 plus 1, which is negative 7, which is exactly where I started. I don't care which way you do it, as long as you know that you cannot start until you get to x equals 4. I went ahead and made an open circle here because it's not including 4. And I actually need to keep going and make some more points there, right? I could keep going down 2 over 1, and it would look something roughly like that. Oh man, this is a crazy one for domain and range. Yes. Because there's no boundaries up here that say between, like this is between 2 and 4. Do you agree with that? There's nothing up here that says there's a graph that's in between just 2 and 4. So if you just go by what the boundaries say, it'll tell you which section to use. But if you have more sections than equations, there will always be 1, maybe 2 left over, depending on how many different sections they make you cut it into. So the domain is the x values, and I was kind of trying to hint around at this one. I'm going to go down here so we can see my whole graph. I have this little section down here, and it comes up here, and then it skips, and then it comes over here. On all the other problems where the domain was all real numbers, our graph had a piece in every section. If there's a section without a graph, that means your domain is skipping some x values. So that's the way that I know this is not all real numbers. What are the x values never used in this piecewise function? 3 is not used. What about 3.5? What about 3.76238? We can't just say 3 is not used, right? Right? 4 is not included either because it's an open circle. But 2.1 is not included, right? Do you agree? So the whole interval between 2 and 4 is not used. And so let's write that in interval notation. We can say our domain starts at negative infinity and it's continuous. It uses every x value until, where does it stop? X equals 2, yes. Is 2 included in my domain? This is a closed circle. So it's going to go from negative infinity to 2, and then it stops, and then where does it pick back up again? At 4, and is 4 included? So then I have a union between parenthesis 4 to infinity. Because although this is pointing down has nothing to do with my x values. These x values are going to get bigger, and every x value will be used. So domain will be something other than all real numbers if you have a section of your graph that doesn't have a piece in it. What about the range on this one? This one's crazy, I feel. Maybe not that crazy, but... Definitely negative infinity because both of these arrows are pointing down. Does this arrow cover the same amount that this arrow covers?
Oh, that one.
Could the range of this one fit into the range of this one? You see what I'm saying like that? Like, this one starts way down here like negative 12. But since this one starts above there, I don't need to include negative 12 in my range. You want to kind of think about the overlap here. Someone said negative infinity to 5. I definitely agree 5 is up there. But are all these numbers in between here used? If the point's included? Well, it's not up to 5 because is 0 included? Like well, no, 0 is included. No, it's not included. 0 on my y-axis. Do you agree there's no part of my graph at 0? And what about here at negative 3? Is there any part of my graph at negative 3? My graph is definitely at 5. Like, we could actually say, we can go over here and say, we have that one little point here again. But there's this big gap, like from here all the way to here, there's no y values being used in there. Does that make sense? My y values start way down here at, what was this, negative 7? And so we have to say it only goes to negative 7, and then it skips to 5. Is negative 7 included? No, because it's no circle. It's redundant to say, or it's repetitive, if you also said to negative 12, and then from negative 12 to negative 7, because it's continuous there. I wouldn't count it wrong. On the homework quiz, on some intervals of increasing, some people said from like 1 to 3, and then from 3 to 5, and 3 was included in that. Well, I wrote in a lot of people's papers, like if you say from 1 to 3, and then you say from 3 to 5, couldn't you just say from 1 to 5? Right? Like there's no need to include that if 3 is included on both of them. Does that make sense? So I didn't mark it wrong. I just showed you that there's no need to say that. Like your domain and ranges could get really awful if you include those things that repeat themselves. It's not wrong, it's just repetitive to say. That's some exciting stuff today, right? All right, I think you have all graphs on your homework. Maybe not, but let's see. So same paper I gave you yesterday, 12, 14, 15. And I look at 18 and 19, which aren't so bad to go backwards, but here's what's bad about 18 and 19, is your graph is going by 2s, and I find it really hard to read. So really, I'm just going to take 18 and 19 off of this. Just because as I was doing it, it's not terrible to do, but it's hard to remember that your graph's going by 2s and to count your slope when it's going by 2s to write those equations. So you only have 12, 14, and 15, which is 3 more graphs that you should be able to fit on the back side of that graph paper I gave you yesterday. If for some reason you need more graph paper, just let me know. on your homework. It's not on your assignment sheet. If you want to add it before 1-3 and just put worksheet up there so you remember, you can. You don't have to. But this will go with your assignment sheet, and you will turn this worksheet in, the work for it, on the day of the test, okay?